All right, so we are looking at this question. A cylinder of conducting putty has length L, diameter D, and resistance R. The putty is now molded into a cylinder of diameter 2D that has the same volume. The emphasis here is the same volume. Please take note of that. So, which means the volume before it was molded is equal to the volume after it was molded. So I can say V1 is equal to V2, which I can further break it down to say that my area 1 length 1 is equal to area 2 length 2. All right. So this has a circular cross-sectional area. So the area we can say is pi d1 squared over 4. So that's an area of a circle. That's pi d squared over 4. Then my L1 must be equal to pi d2 squared over 4 times my L2. So you can see clearly that the pi and then pi over 4 can cancel out. So this goes. All right. Now the question says initially the length is L. So which means that my L1 can now be L and my diameter was D. So my D1 can be D. That was the what was given the question. So I have here D squared L is equal to, now after it was molded, the second diameter, which is which would be D2, was doubled. So which means that the D2 squared here now becomes 2D all into bracket squared. Take note of that, very important. And my L2. So which means that from this I can find my L2. So if I break it down, I have D squared L is equal to 4D squared L2. So my D squared can cancel out. So which means that my L2 is actually L, the first L, divided by 4. So very important. Let's keep note of this. Very important. Now we come to our resistivity, because it's of the same material. Because the same conducting putty is the same material, which means that the resistivities are the same. So which means we can equate the resistivity equation for before it was molded and after it was molded. So that brings us to R1A1 over L1 equal to R2A2 over L2. But remember, we are dealing with diameter, so you can express the area in terms of diameter, and you can see clearly that the pi over 4 will cancel out anyway, so we can continue with that. So that brings us to R1 D squared, so which means that instead of the A, with respect to, if you want to write it with the diameter, it has to be squared because the pi over 4 will cancel out anyway. So I have here R1 D squared over L1 equal to, so this is D1, equal to R2 D2 squared over L2. So let's try and put what was given the question. Our R1 in this case was R. So I have here R, and my D1 was D. So here becomes D squared over my L that was given should be equal to my R2, which is what we are finding. That's what the question is saying. It said, by what factor does the resistance of the putty cylinder decrease? So what you are looking for, you are looking for R2 with respect to the R. So that is what we are looking at. So my diameter here now becomes 2D all squared over, remember, we found our L2 here, which was L over 4. So which now all you need to do is to rearrange it and make R2 the subject. So with that, I do my mathematics. So I have my R d squared over L, which is equal to, so the 2 becomes squared. So here becomes 4d squared R2, but I can bring my 4 up. So if I bring my 4 up, the 4 will multiply the 4, which will be here already. So this will give me, so let me make it, so here becomes 4d squared, let me make it better. So here becomes 4d squared R2 over L over 4. But I can bring the 4 up. So that will be RD squared over L is equal to 16D squared R2 over L. So I can cancel my L. I can cancel my D squared. So in effect, what I have here is R equal to 16R2. So my R2 will be equal to R over 16. So which means that my new resistance, you can see that it has decreased by a factor of 16. So therefore my answer is D.